Hello everyone, today's question is about turning effect of force. A uniform meter rule is balanced at its center. It is balanced by the 30 newtons, 5 newtons and the magnetic force between P and Q. P is fixed and Q has a weight of 5 newtons. So we have the diagram here, just as described. Then part A, ignoring the weight of the meter rule, calculate the value of the magnetic force between Q and P. And finally, part B, given that the lower end of Q is North Pole, state the polarity of the end P facing Q. So first of all, we need to note that this question is based on the principle of moments, which states that at equilibrium, the sum of clockwise moments about a point is equal to the sum of anti-clockwise moments about the same point. So considering this diagram, we have the pivot at this point. So the forces that will cause moments here are as indicated. So we have 30 newtons, and on this other end we have a total force on this side acting through this point. So let me have it as this. So let me indicate it as F. Now this force here includes both the magnetic force and the 5 newtons force here. So applying the principle of moments, we will say the sum of clockwise moments equals the sum of anti-clockwise moments. That is about a point when the system is considered to be at equilibrium. So here we want to identify the force that will cause clockwise moments. So we have force F causing clockwise turn or moment, and force 30 would cause anti-clockwise turn. So for clockwise moments, we'll use force F times the perpendicular distance up to the pivot, that is 30 centimeters. So we'll say for clockwise moment, we have F times 30. And then for the anti-clockwise moment, remember it's only F on this other side. So for the opposite side of the pivot, we only have 30 newtons. So we'll say 30 by the perpendicular distance, which is 20. So 30 times 20. Here we'll get the force as 30 times 20 divided by 30. Remember, we're dividing both sides by 30 to get F. So F is 20 newtons. So that is the overall force acting on this side at this point here. So remember, the question required us to get the value of the magnetic force, between Q and P. So this force 20 newtons should be equal to the sum of the magnetic force and the 5 newtons that we have here. The sum of this and this, all these should give us force F. So we have magnetic force plus 5 newtons. So the magnetic force as we are required to obtain becomes, so the 5 newtons crosses to the other side and we subtract. So we have 20 minus 5, and that is 15 newtons. So the fact that the force is positive here, it has some significance which will help us in answering part B. So let's move to part B and get to understand the question. Given that the lower end of Q is North Pole, state the polarity of the end P facing Q. We are told that the end of Q is a North Pole. So down here is a North Pole, this end facing P. So we are required to get the polarity of this end facing Q. So what polarity is this end here? Now, because the magnetic force is positive, that is positive 15 newtons, then we expect the magnetic force between P and Q to be an attraction. If we have attraction between Q and P, then it means these ends must have been having a different polarity. So if here is north, then this end is a south. So we have this is south and this other end north. So the answer to this part is south pole. Remember, we have to state the polarity of the end P facing Q. So with that, we come to the end of this question. Thank you for watching. Hope to see you in the next video. Bye.